Welcome to this second part for the computational fragment-based drug design done with the MED-SuMo software. The results that I'm using and the graphical user interface are available for download for a free trial using the MED-IT website. Let's go to the graphical user interface. This is the look that you should have if you install that correctly. You have to go to work offline and then you load the run. And we will load the 1xkk, which is the EGFR. It was previously described this result table in the first video, so now I will just go directly to the MED ligand to show you how those fragments can be used to design some hit compound. Let's click here to hybridise the compound with all hits. There are two small filters that I would like to do, because if I can reduce the number of fragments without reducing the information, then I will save some time during hybridization by combining the fragment. The first filter is to make a 3D duplicate that will remove the same fragments which are occupying the same position in the binding site. You see that now we have only 202 among 400. I swap with the input. That means that they are now on the left side and I can forget about the right part. The second filter I can do is to calculate the interaction between those fragments and the query by doing the PLP intermolecular term, which is now here. I can sort by clicking on the header. And you can notice that there are very negative ones which are likely to bind and very positive ones which are not likely to bind. I will just remove those which are very high, like higher than 50. By making a selection with the left button, and now I make a right click and I do edit and delete. Edit is also available here from that menu. And now I have 189 fragments ready to be hybridized. There is something important during hybridization, is that you can set up rules on the fly by going to this filtering rules editor. I can remove the previous rules that were saved. I will add a remove of molecules which have internal clashes. That means that they have remove molecules that have a bad 3D conformation, like with overlapping chemical moieties. I can just add that. And I will also ask to have a compound which have a minimum molecular weight of 150. I click on add. Now I have that. There are other filters that could be used. You can ask to have some given 2D structures in your hybrids, some given 3D structure. That means 2D structures which have a given position in the binding site. You can use also the similarity tab to bias the hybridization against some molecules, like for instance some non-actives. I click OK, and I can now launch the first hybridization step by going to the Hybridise menu and hybridizing input to input. That means the left side using the chain combine algorithm. It's pretty fast. I have now to the hybrids here. Usually it's needed to make at least 3 steps of hybridization. 4 is good, but 3 is okay. And for this, as the molecules are growing after each step of hybridization, we can change the filtering rule editor and ask the molecule to have a molecular weight higher than 200. I click on OK, and I can do now a second step of hybridization by combining again the same fragments to the resulting hybrids of the previous step by doing input to output. And then I do that. I stop the recording to save some time. The second step is finished. We have now in this second step like 7500 hybrids. Let's go for the third step. Again, we change that and put molecular weight which is higher than 250. And we launch this 1, 2, this third step of hybridization by clicking input to output chain combine. And I stop the recording again in the meantime. Okay, it's almost finished. That's the third step. I would recommend you to, if you try to reproduce those results, to stop at 3 steps. I know it's already enough, and well, as I have 8 GB of RAM on my machine, I will do for this demonstration a 4th step of hybridization, and I will go to the filtering rules editor, and I will not only ask to have 200 and 50, but also I will ask to have a molecular weight which is less than 650, because the query ligand is like a little bit more than 600, so that would be nice to see if we can generate it back. So I add this, I click on OK, and I launch this 4-step of hybridization. That you will see that it will take some time. You can see that on the clock that I have on the left bottom part of the window. So let's launch that. That's 4th step, and switch off the recording. Okay, that's almost finished now. We have 49,000 hybrids for this step. Something that we could do if you would like to have some compounds that are very close to non-actives. That's very useful actually to have compounds close to non-active, because you may have the pose of those non-active in the reference frame of the query. Because remember that those hybrids are in 3D. But at this step we will just keep all those hybrids the way they are. Some of them are close to non-active, some of them are different. However, we keep all of that. We will make a single file containing all the steps. So we go back to the first step and we make add to input. The second step also we add to input. The third step we add to input. And the fourth step we add to input. And we can now forget about the right part. We have now in the left part all those hybrids, which are like 74,000. We can make a filtering on 3D duplicates that will have, now we'll get a smaller number of compound, which is 31,000. We can swap with input and forget about those 5. So now we have quite a lot of hybrids, and we can finish that short video by scoring them using the ligand protein descriptors PLP intermolecular term. That if you and once it's finished, then I just go on that column header and sort them according to this term. It takes some a little bit of time because the array is pretty large. Here we are. So we have now the most negative ones on top of the list, and you see, for instance, that one is very close, if not identical, to the query ligand, which is retrieved, and there are quite a lot of them that could be investigated. So what we usually do to investigate those, we search them into libraries and using the search wizard, and you can search into target files. Like you can search into non-actives, you can search into compounds which are known to be active, or in chemical libraries. I will demonstrate that in the next video, which is the part 3, which is the following one.